wrap all 3 of these yesterday? You don't think so? Do we need more time to solve them? So pull out your work from yesterday. Pull out your work from yesterday.
That would be my locker. I go grab that.
Yeah. You should bring it to class with you. This shouldn't be like a thing. So, someone's going to have to catch up, Chris, on what the goal is. Our goal for today is finish parts A, B, C here. Then we're going to do this pentagon to make sure we can apply that with the pentagon. We'll quickly apply our same knowledge base that we used up here to help the rowdy rodents. And then we're going to jump over into 831 and see how far we can get. Okay? So that's our goal. I'm actually going to go ahead and here in a couple minutes just put the answers for A, B, and C up so you can check if you got it right. And if not, go back and find that mistake. So I will freeze the screen there for now and get to those answers. And if you are not done with that yet, keep going to try to get those finished. Blue sheet things? What do you mean? Oh, over there in the blue little containers that where they're supposed to live, but you guys never put them away correctly. Because now I'm guessing you didn't know they were there. They look cute. Yeah. And there's also blank paper. Thank you, Jacob. Yeah. Remember, we can use our trigonometry knowledge. We did.
I don't know where it went, but I did it wrong anyway, so.
We discussed the non-gon, right? We're done with that?
Yeah, but I want to try to do it again. Didn't get it.
That scared me. I'm going to write work up here, just making sure that I'm not going to burst anyone's bubble. Oh yeah, so Steven, you missed out on what we were doing yesterday. Does this make sense? What we're trying to accomplish here. We're taking what we know about the polygon, what is given to us, like such as in the non-gon, we know there's 9 of those triangles, and we're able to find this central angle by saying that 360 divided by 9 would leave us with 40. And if that's our central angle, we can split the base angles with the remaining degrees. So they end up being 70 each. We can drop an altitude. That would give us hypotenuse 11, base angle 70, and then we can use our trig to determine the missing sides. What's B? What kind of shape? How many sides? Decagon.
What was A again? Wasn't it like...
I might as well just show the answers. I was just delaying, but you might as well just be able to check. Up on the TV are your answers.
Dang it. I keep doing this wrong.
350.1.
Oh, on top.
Yeah, up on the TV.
Oh, yeah. Didn't we go over?
Yeah, we did. Chris is just trying to resolve it because he had made a mistake yesterday. 36 degrees, 180 minus 36, 50, 44, 144, 72.
I forgot to multiply it.
I think those base angles in a decagon are
What's that
72.
heck? Okay.
Sorry, I feel like the air turned on.
Oh, that's Detroit. I know why it's Detroit. Alright. So, this is...
So when we do the trig in B, what do we get for an edge of the decagon? Anyone have that?
Figuring that out now.
So I could use opposite adjacent, so I could use TOA, or I could use tangent for opposite adjacent. Because we know the opposite. So we set up tan of 72 equals 5 over unknown. But unknown, remember, is only that section, not the entire bottom. So we actually have to do 5 divided by tangent of 72. 1.6. Check your mode. Make sure you're good.
Yeah.
So leave it in the calculator and double it. 3.249. So really like 3.25.
I did get this one right. I got C right. A, I
6 is
forgot to
testic
multiply by
hexagon.
two. There are two of the right triangles.
6 is a regular hexagon, so even though I made this triangle look the same as that one, remember as we discussed yesterday, don't trust what it looks like. So this top angle is hexagon.
It should just be
60. Right, central angles split of a hex for 6. 360 divided by 6. I can say 6 a lot more times if you want.
6.
This then, 6 equilateral. Oh, well that's an odd looking equilateral triangle. We have 4 on the bottom, which means we have 2 on each section. So we have an adjacent. We're looking for an opposite. Again, we're using tangent. So tan of 60 equals height of the altitude over the adjacent.
What did I do?
Check your mode. 2 times tan of 60.
No, it's the,
Wait, but
oh,
it's not a right triangle yet.
I deleted
When you split it
previous
up,
answers
Or are you
so that I could go back
I'm
to the
using
numbers
this
that I
60.
previously
30,
calculated.
60, 90.
And then I tried to multiply
multiply
by
by
8, and
2,
it
4,
just
and then 2 radical 2.
calculated off the number there.
2 times radical 2.
There's like 4 people talking at the same time, and I think you're all saying the same thing relatively.
Oh, yeah, 2 radical.
Remember, the 45-45 uses radical 2 because it has 2 matching angles. the 30, 60, 90, they're all divisible by 3. We use radical 3. So this is what? Radical 3 of 2?
2 radicals.
It's 24 radical 3 units squared.
Which really comes out to like 3.464. Almost 3.5. And your hypotenuse, we don't need it, but what would your hypotenuse be here? 4. Which makes sense because it's an equilateral triangle, right? So even though it doesn't look it with how I've drawn it here, this is an equilateral triangle, which, well, first we said equiangular actually, and then we know it's equilateral. Anytime we get this triangle area, we then multiply by the n of the n-gon. Correctly done. Missing Satya and moving and more indefinitely.
Yeah, the one just the science there was silly. And then Santi's just not here for whatever reason.
Sati probably has a terrible headache.
Any questions on ABC?
He's got the headache. Sick.
So obviously they leave C, they can leave it in simple radical form, or put it to decimal form. So to check that we're all comfortable with this, let's solve my desktop. Let's solve the amount of fertilizer needed to cover this pentagonal area of land. Another odd one, right?
Wait, hold on. Can we go back to B?
I will put the answers back up in a second.
No, I don't want the answers. I just want to do it. Chris, get a book.
Yeah, he's got a point.
Yes, but also.
Yes, but it's far away.
Yes, but it's like such an effort.
It's so weird that you've got your computers like put up like that, so you can just drag one
I mean, it's still
to the
weird.
left
It's
and it
sensible.
goes up.
Well, because I don't really have a mount for my screen.
No, I know. It's just interesting.
You know how to set that up, right? You just go into your properties. So I could move it to make the screen act like it's on top, but that would confuse me over here. You know what I
You
mean?
could just move your computer on top of the other one. And that
Yes,
would work
that's
very well.
no big issue. Just make it float in space. So are you doing B or not? Chris,
Yes.
are you doing B or not? It
Yes.
doesn't ask for me to wait.
Okay, there we go. So this is, alright, thank you. That's all I need.
Yes.
Should be 15 and 54.
All you need to know about your pentagon is that the edge is 15. That's all you really care to know. Yes.
6'5" Levi. That's like a knitted thing.
Non-rate. So you just hide in a corner and cry.
Did you know that beans and sadness is the national breakfast of England?
I doubt it.
Beans and sadness.
I
I don't think
You might go out on a limb and say they don't eat
Well, I
salmon.
mean, when I was there, we ate beans and sadness every day.
For real.
Levi, did you get Levi, did you get 387?
Okay, what's the answer for B?
Figure it out, Chris.
Is it 81?
81.2.
Yeah!
All right, now move on to our pentagon here so I can put that on the screen. Oh, 360 divided by 5? Who made us do that? Hold on, what's 360 divided by 5?
72.
Wow, it's almost like.
Okay, what's that?
Can I have a calculator?
No.
Please?
What, you want to do trig or something fancy like that?
Yeah, I don't need to put trig or
Well, it was mine in the first place.
except for like any other English problems.
Jacob took my land. Well, it was my land in the first place. Whatever, Jacob. Shut up. You don't know anything about land.
So wait, what's our base angle down here?
60.
Hmm.
Or no, it's not.
Hmm.
Isn't it?
Yeah,
No.
it's 18.
44.
Or, no,
What?
no, it's not.
180 minus
These need to be 90.
Oh yeah, 54. All right.
This is 7.5. Bless you. It's adjacent, or it's opposite, depending on how we want to look at it. Hmm. 7.5 times tan of 54.
I believe so.
Yeah.
I mean, with that, I got 10.3228644.
I got 867.3. I was gonna see if anyone caught it.
Oh wait, from the song.
86753. But instead of saying 5, I said point.
Yeah.
867.3. All right. Anyone else get the height of 10.322?
Yep.
Things.
It's 3.323, but whatever.
So fun thing that you should be getting comfortable with. If I'm looking for this entire triangle, I don't have to divide by 2. I can just say 15 because it's the whole base times 10.32 would give me the whole thing. But if I use 7.5 times 10.32, I don't divide by half. I double this way and then I multiply by 5. And we get
387.
No, if you multiply by 15, then you get 2 of the triangle.
387.
yeah. Sorry, I said 2 different things at the same time. Like I said, you could do this and have to multiply by half, or just do this and leave it how it is. So that's why I use this. But you have to do times half to find this area. But if we don't times half, we're finding both areas. So I use
And what was your answer?
77.4. Area, total area of pentagon being 387.1.
Yeah.
So each triangle comes out to about 77.4.
Mm-hmm. Yeah.
So then, if we convert to bags of fertilizer, we would need 3. And that's real world, like you do that every spring, trying to figure out how much stuff you got to go to Home Depot and buy to make your yard not look bad. With me, Chris?
8.
Yes. 8 bags of mulch is enough for you?
Yes.
I normally have to buy like 20.
You don't have much more.
All right. Then, do we think we could do this?
Probably.
I think so.
I wonder how quick we could do it.
Okay.
You think you can do it in 2 minutes?
I did it in -5 minutes. Does that mean?
Well, it looks like Thomas wins.
You don't need to see these. There's 2.
Dividing by 8 isn't too bad. We could cut in half and half and half again. So 180, 90, and then 45. Making each of these central angles 22.5, I believe.
Then we can divide 2 by radical 2. We know the sides.
By radical
Or no,
2.
wait. No, it's not, because that's 22. Never mind.
Yeah, you don't have a 45 triangle, you have a 45 something. But then if we make it a right triangle to do our trig, we don't have a 45, we have 22.5. Leaving the other angle at 67.5.
Okay. Sine 20 equals x over 2. 2 sine 20.
2 is your hypotenuse, so we got to use sine or cosine, depending on which angle we choose. So if we're going to choose the 67.5, and whether it's sine or cosine, the hypotenuse goes on the bottom. But if I want to find the height here, yeah, crap, I need to find both. I'm eventually going to have to use both. Right? If I use sine, that gives me opposite over hypotenuse, so that gives me the height. But if I use cosine of the same angle, that will give me the base, right? That, but half the base, right? So this B is half of one of my edges. It is half of an edge. So if we use sine, we do 2 sine of 67.5. What do we get for the height? Stop it. Don't say one thing and then say a different thing. And then your little edge section.
The tiny one would be 0.765.
So one of the edges would then be
1.531 if it's rounded.
We are very small.
Yes.
10.11153312.
Are we comfortable with this work?
Yes.
Now you're probably going to laugh at the next lesson.
Okay.
Not for what it is, but for what math it asks you to do. So, are we all saying that we don't have any more questions on this? The trig applications, drop an altitude, make a right triangle. Double check your angle measures, double check what you find, whether it's half of the edge length or the entire edge length. Just things that I've seen mistakes in the past. Trying to warn you about.
Go into like other bases.
Hmm?
What's the answer for it?
What do you get when you multiply 6 by 9?
Where'd the answers go?
Did you X out of them, Hudson?
I did X out of the answers.
Jacob, why do you call your teacher by their first name?
What do you mean?
He said Hudson. I know.
Like John's his last name.
It's not very
Hudson is the
respectful.
last
Yeah,
name.
it's without the honorific.
Hudson's the
That's like me just yelling.
Anybody can call me just Hudson. It makes me more comfortable.
That's
Mr.
your last
Hudson's
name.
still kind of weird.
Okay, Hudson.
Seriously.
That feels
Weird.
weird.
That feels more weird. Feels more weird.
And I'm not even saying. Darn it.
Okay. So what's the next thing? What's the next thing? Is it,
The thing that you're going to laugh at?
Ooh.
All right.
You're gonna
So
laugh.
I am going to put forward to you a question that I want you to discuss and come up to an answer as a team. The Rowdy Rodents have decided that they are going to up the size of their pennant. So a pennant is, I have one somewhere from Otterburn, maybe it's down here something. It's a thing for your school, right? For some reason, people a while back decided we're going to make fabric triangles that people are going to have for the school, and they'd be like on a stick or something, it'd be like a flag.
Yeah.
So
It looks like
then eventually they just started, like, you would hang your pennant vertically, but the text wouldn't be the right way, and a lot of people have turned the direction of how they make their pennants. So the rowdy rodents have a pennant that measures 1 foot wide and 1.5 feet tall. They decide they're going to up it to twice its size. So Archie figures that, well, must be $2 worth of material to create this because it's double the size.
oh my goodness, he's so dumb.
So discuss with each other what you think
Go away.
about Archie saying that the new flag will be double the original.
Nope, wrong. It'll be like 9 times.
Wait, where is this question?
It's in 831. I did not print the resource page because it's lame and it's unnecessary.
It's 4 times the original because it has to be. Right? Okay, so.
Don't look at me.
Okay. So if we've got the pennant thingamabob and we know it's 1 foot by 1.5 feet, got 1.5 square feet, right? And that's
Yeah.
the amount of flag that there is for the original, for the little flag. So when we double it, now we've got 2 by 3,
But-
so then it's actually
but-
6.
Stop.
6
Does the height scale?
Yes, it all
Are you
scales.
sure?
I think the final flag should be 3 feet tall.
Are you sure?
How wide would this enlarged flag be? I'm pretty sure we're just scaling the flag up.
I
It's
think.
Do you have a conjecture then about how we could create a rule? Please stop helicoptering. I'm just waiting for it to fly off and, like, I don't know, smack me in the face.
I already kind of know this one. I watched a video about an elephant exploding. Or no.
Do you have a conjecture?
That the elephant
Sort of.
definitely.
What's your conjecture?
When you dilate something, when you dilate the length of something and keep the rest of it like scaled with it, the amount, the actual volume of the area will scale by the square of however much you scale the length by.
Okay. It's an interesting conjecture.
So
We're gonna
doubling it, and
Then it would be 4
we're gonna scale the area to the scale factor squared. Okay. So if something then is 100 times larger than the area of a similar shape, your area comes out to be 100 times larger. What was the scale factor? 10. Right? Because if I multiply, think of a 1 square by 1, like 1 by 1 square compared to a 10 by 10 square. Right? We go 10 this way. Oh, that makes sense because my scale factor applies both length and width, so it applies twice. So then, if Kelly is working with this odd lake-shaped object, and
how do you know what a lake is shaped like?
I mean, come on,
What
this
is
is the
the
best.
lake shape?
Because each of these, we could call each of these. Yeah, this looks like a witch's hat, right? So, if she enlarges the shape with a scale factor of 5, how will we modify the new area?
It'll be 25.
Times 25, right? If she goes linear scale factor of 5, it'd be area scale factor of 25. So, wait, with the witch's hat, what is the linear scale factor?
4.
So to find the area of the tiny one, you divide by 16.
Linear scale factor is 4. So, how do we find the area of the little guy? Jacob just said it, but
Divide by 16.
divide by the square of the scale factor, not square root, but square.
41.
And this has an area of 41. I don't really think we need to do C. Look at D! When Trin tried to order carpet, he, I don't know why, said it was 16 by 24, when he then realized the room is actually 8 by 12. That's a big bubble burst right there. So the salesperson says, right, half the size, half the price. There you go.
You little. Trin just like. No.
What? Okay, yeah,
Fun
good
to, like,
idea.
It'd be fun to like argue with with like the salesperson over why it should only cost a quarter.
I've had these conversations with people before.
It'd be so fun.
So,
Wouldn't it be?
funny enough, we ordered donuts for 7th grade this morning. 10 dozen was cheaper than 8 dozen. Because with a pre-order, there's a price break at 10. So up until 10 dozen, you pay a certain amount per dozen. But at 10, the price drops. So you remember when we did those piecewise functions? That would say, like, okay, my price is increasing, increasing, increasing. So here's price compared to amount of donuts, right? Up, 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 up. Then we hit 10 donuts, or 10 dozen, and it went down to, like, here. And started, like, actually on a lesser slope, so it wouldn't be parallel. It would be a lesser slope. So we, at 8 donuts, were, like, right here, or at 8 dozen. But then 10 dozen drops you down below. Like, it was really weird, because we were on the phone with the guy, and we were like, oh, well, yeah, okay, sure, do that.
Wait, do you have any extra notes?
Can you give your sweet math class?
Maybe.
We're in 7th grade.
I mean, didn't we just complete 2 lessons?
I mean, he's not wrong.
You're not wrong, but you're about to head to lunch.
So?
So that's the best
I
time
can
to
take
have
it to lunch.
Yeah.
We'll see. So, if this linear scale factor is 3, thank you, Hunter, then the area scale factor would be 9. So guys, the whole point of us reviewing this information is when we work with regular polygons, you should start to kind of have a knowledge base built up of if you solved a hexagon with edge length 10 and you have a hexagon with edge length 42, okay, your scale factor is 4.2. Square that, and you have the new area. You don't have to then multiply, right? So you don't have to recalculate everything every time. This is why we love regular polygons. Most things you see out in the world, are regular, unless, like, if you ever look at something, you're like, oh, that's modern. Like, that looks like, normally that's non-regular. Like, modern, more like new type design doesn't use as much regularity, but that's what, like, our brains are wired.
Construct without using regular.
Well, our brains are hardwired to, like, identify, oh, that's regular and it looks nice, and but so now they've switched it to instead of like, oh, that looks nice. Now it's like, oh, look at that. Like, it attracts your attention because it's awkward. You know, like, not in a bad way. I keep getting screwed up over by that like, I'm pointing out in the world. Where that new house or new apartment complex is going in at the old Andersons, because everything keeps changing every time I'm over there, and it's just messing with my brain. So we have 10 minutes. You can work on your homework. Donuts. Code words, donuts. Is it just the 6 of us? Right. That's.
Well, 7 including you.
Do your homework. I'm gonna go to the office.